On this part, we're going to do some more examples as well as go over this AP exam tip. So it says exponentials are more powerful than polynomials. So as when x is approaching infinity. So an example is if I get just some number, like if I get just a single number like 1, 2, 3, 4, 5, just stuff like that, that's not going to be as powerful as x. So if I had like x on the bottom, so that is changing as I plug in limits as an infinity. So x's are getting bigger while these are staying fixed. So x is more powerful than just a number. X squared is more powerful than x. X cubed is more powerful than x squared. X to the fourth is more powerful. Okay, you get it. Okay, then the next one would be like an exponential, like some number to the power of x. So like 2 to the power of x. 3 to the power of x would be more powerful, would be bigger. 4 to the power of x would be even bigger than that. And then the most powerful, something we'll talk about later, is if I had x factorial. Now factorial, just a little side note, like 5 factorial is 5 times 4 times 3 times 2 times 1. So all the way down to 1. So at infinity, if I had x factorial, this is actually bigger or more powerful than if I had like 1,000 to the power of x. Because remember, we're talking about at infinity. So if I have huge numbers, like if I had 1 billion factorial, that would be bigger than 1,000 to the 1 billion. Okay, I'm just not counting zeros. Because that would be 1,000 times 1,000 times 1,000 times 1,000. But 1 billion, I'm not counting the zeros, that would be all that times a little lower, I'm not counting this, times 1 lower than that, on and on and on and on and on and on. So factorial is actually going to be the biggest thing. It doesn't happen for now, but it will come at some point. All right, so let's use these examples to kind of just do some more. All right, so notice we're looking at x's approaching negative infinity. So if I had a negative infinity, what is the biggest degree or the biggest magnitude? So the biggest magnitude is on the top. So if you wrote negative infinity, I'd probably give it to you. But I want you to write does not exist. The horizontal asymptote does not exist because I'm doing negative numbers squared times 2. That's going to blow up. The top is going to be infinitely huger than the bottom. So that there's a number and it keeps getting bigger and bigger and bigger and bigger and bigger. The bottom doesn't hold it down. All right, the next one, the limit as x approaches negative infinity. So like if I'm looking this way, and by the way, we can have 2 separate horizontal asymptotes. We're going to talk about that later. One at positive infinity, one at negative infinity of the same graph. All right, so if I was to multiply this out, this would be equal to the limit as x approaches negative infinity of just 16 x squared plus minus blah, blah, blah. I don't care. The biggest part is going to be that. On the bottom, it's 8x squared. So negative infinity squared is still going to be a positive. So it'd be a positive 16 over 8, which is just equal to 2. All right, so next one, this is saying the limit as x is approaching infinity. And I kind of wanted this to be negative infinity, but we'll do one in a second that does negative infinity. All right, so there's something we need to remember. And if you have a calculator of your own, I want you to graph y equals the absolute value of x squared. That's not what I want you to graph. That just told you the answer maybe. All right, graph the square root of x squared. So if you graph the square root of x squared, you're going to see this v, which is the absolute value of x. So when you take the square root, so if you have an even index, and this is an even exponent, but when you take the square root, it's an odd exponent, then you need to put absolute value bars around that. If you don't, it's not technically right. Because I could plug in negative x's, square it, and that would give me the same thing as if I plugged in that positive x version. So just something we need to a little memorize. You might want to write this on your memory sheet. If you ever see the square root of x squared, just know it's equal to the absolute value of x. All right, so with that being said, this would be equal to the limit as x is approaching infinity of 2 absolute value of x plus some smaller stuff, right? Blah, 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 over just 7x dot, 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 dot. All right, so if I'm looking as x approaches infinity, these have the same magnitude on the top and the bottom. So the absolute value of x looks just like x, but in the negative version, it would be going up instead. So this would equal 2/7. Just look at those coefficients. All right, so next one. Okay, this is the first one where we have something kind of tricky going on. We have a huge exponent on top, but we have an exponential on the bottom. So we said a second ago, the more powerful, says exponentials are more powerful than polynomials. So here's our exponential. Can't spell it right. Those are more powerful than these just polynomials of different degrees. So if you think back, what is e? E is just some number, right? 2.72, some going on forever. So this would be, okay, which one's more powerful, the top or the bottom at infinity? At infinity, the bottom is going to grow infinitely larger than the top. So if the bigger degree is on the bottom, this limit would just be 0 because the exponential part dominates. All right, so this next one's kind of tricky. I want you to pause it, see what you think you would get, and then come back and see if you got it. So pause, think about it, try it. Okay, coming back. If you wrote 1, good try. It's actually not. If I was looking at the limit as x is approaching infinity, positive infinity, it would absolutely be 1 because the biggest magnitude is the same on top and bottom. Like the adding 4, the subtracting 3 doesn't matter. But if I think about it, I'm going to plug in a big negative number, like 2 to the negative, not big negative number, 2 to the negative 5. So I got 4 plus 2 to the negative 5 over 2 to the negative 5 minus 3. Okay, what does a negative exponent do? I would change this and make it 1 over 2 to the 5th. Now exponent is positive. This would be 1 over 2 to the positive 5th. So now it's positive. So what would happen if I kept plugging in bigger and bigger numbers for instead of 5? I mean, this fraction would approach 0 because the bottom is getting huge and the bottom is a number. This fraction is getting closer to 0. So the actual horizontal asymptote is just negative 4/3. It's just these 4 plus 0 over 0 minus 3, so negative 4/3. All right, next one. The reason I wanted you to remember that y equals, or just, I guess we don't need the y. The square root of x squared is equal to the absolute value of x is because this would tell me the limit as x approaching negative infinity would be equal to 2 absolute value of x over 7x. Now, if I plugged in big negatives on top, that would just be a positive number, right? 2 times a positive huge negative, or 2 times the absolute value of a negative number, which would be 2 times the positive value of that number, right? But if I plugged in that negative infinity on the bottom, so basically, how am I trying to say this? This is negative 2/7 is the answer. And if you get it, great. So if I plug in a big negative, the negative goes away on top because of the absolute value, but the negative doesn't go away on the bottom because there's no absolute value. That's a really, really, really tricky one. All right, see if we can finish this up. All right, the definition for horizontal asymptote, y equals L, is a horizontal asymptote for the function f if the limit at infinity, as x approaches infinity, of the function is L, or the limit as x approaches negative infinity of f of x is equal to L. So write this on your memory sheet. This is something you need to memorize for the AP exam. No, when finding horizontal asymptotes, we must consider both limits because there could be two different horizontal asymptotes. We check both limits when working with, the main thing we need to check is when we're looking with square roots, because if you take the absolute value, or take the square root of a even index, or square root of a even exponent, it turns odd, and then exponentials. And if you look back at it, these were exponentials. At negative infinity, it goes to 0. At positive infinity, it would have gone to 1. Or no, at negative infinity, it goes to 4 over negative 3. Positive infinity goes to 0. We'll do an example in a second. All right, so find the horizontal asymptotes for the following functions. We got to find the limit as x approaches infinity of f of x. So this one, I just plug in huge positive numbers. This stuff doesn't matter. I would get 1/3. So one of the horizontal asymptotes is 1/3. The limit as x approaches negative infinity of f of x. Well, the negative is being squared. The negative being squared, so I would get the same thing. So there's only one horizontal asymptote, and the horizontal asymptote is y equals 1/3. All right. Next one, the limit as x approaches infinity of g of x. Well, the bottom is blowing up. It's getting infinitely huge compared to the top, so this limit will be 0. And at negative infinity, it'll still be 0. It'll just be approaching 0 from underneath. So if you wanted to, like say from, it would be from the top. And then from the bottom, it'd be looking like that. So one of them is approaching 0 from above, one's approaching 0 from underneath, but still approaching 0. The other thing about horizontal asymptotes is your graph could cross over a horizontal asymptote, but at infinity, it gets really close to the asymptote, doesn't touch. So that's something that might be kind of new to you. Your graph can cross over a horizontal asymptote, but at infinity, it's just getting really, really close. All right, so this is the last two is when we really need to check out the positive and negative versions, because I'm dealing with a square root on part C, and I'm dealing with an exponential on part D. So the limit as x is approaching infinity of h of x, I don't want to rewrite the whole thing, would just be 3x, that's the biggest magnitude on top, over 5 absolute value of x on the bottom. Now at positive infinity, I would just get 3/5. The limit as x approaches negative infinity would equal, actually, I feel bad. Right here, there needs to be the limit statement. The limit as x is approaching infinity of this. So this one I'll write it better. Limit as x is approaching negative infinity of 3x over 5 over absolute value of x would be negative 3 over 5. So this one is negative because on top, I'm plugging in a negative huge number, negative infinity. On the bottom, the negative infinity cancels out by the absolute value, so it'd be negative 3/5. So your two asymptotes, HA for short, are y equals positive and negative 3/5. All right, the limit as x approaches positive infinity of k of x is just going to equal positive infinities. These are going to be the biggest things, but they're the same thing, so it's going to be 1. The limit as x is approaching negative infinity of k of x is going to equal to the limit, actually don't write the limit, just plug in the numbers. Now we know at this point, if you think back to that last example, if I plug in negative infinities, that's like 3 to the negative 1 or 10, which would be 1 over 3 to the 10, which is a tiny number. It's approaching 0 the bigger the exponent gets. So this would be negative 4 over 5. So the horizontal asymptotes here are y equals 1 and y equals negative 4/5. All right, last thing. The Determining the asymptotes given the limit statements. So for this limit statement, that looks like at negative infinity, so that's way over here in this direction. What's happening? The limit's 4. That means there's a horizontal asymptote at y equals 4. If the limit as x is approaching a number is negative infinity, that means right there at 3, the graph is getting closer to negative infinity. It could look like that. It could look from, well, I guess from both sides. The double-sided limit has to be the same. So that means there's a vertical asymptote at x equals 3. So for horizontal asymptote, that's a straight, flat, horizontal line, so it's y equals. Vertical asymptotes, straight vertical line, it's in the form x equals. As always, if you have any questions, ask me next time I see you in class.